conventional program and GUI programming. Means console-based programming and GUI programming. Like if we write code in C, Pascal or C++ or any language that we kind of execute on the console, and the program that we see through graphics like windowing system. So what is the difference between them? We can call it non-event based programming and event based programming, or people also call it non-window based or console based application and window based application. What are the differences? Slowly we will move up. But basic, what is the difference? When we write a console level program, then any function we are responsible to call. So the programmer calls the function. But in the event based program, okay, so it is the event manager that calls the function. Means we are the programmer who is writing the code. Maximum what is in hand of a programmer is event generation. He can generate an event, that's it. But if we see in the console-based program, conventional programming, programmer calls the function based upon the situation, based upon the cases or whatsoever. Programmer calls the function. But in the event-based, programmer's hand or in user hand, the maximum is event generation. He can generate the event, like clicking somewhere on the window or selecting some kind of option from the menu or bringing in the dialog box and then filling something and then clicking on the OK. So these all generate events, means whatever I said. So it can be hardware event like clicking somewhere, or if someone kind of click on menu or whatever. So these are called software events, because these are if I click on file, it generates file event, but these are software event in the sense that file is not a hardware, but like mouse event or keyboard event or any event that comes from kind of peripheral. So that is a hardware event. Now event, why there are differences? So we can say graphics programming is kind of higher level programming, deep level programming, or a programming which has too many things to be done. So there means if I talk about the design pattern, then one mediator is required. Means if one person is doing everything, then nothing is required. If two persons are doing everything, then nothing is required. They can communicate. If three people are doing everything, then mediator is required. Means if they start talking to each other, then it will become mess. So rather, they do their job and then report to the mediator. And mediator thinks that who need to be called. So I would rather say that console level programming is a straightforward programming, where an event based programming, window based programming, GUI based programming is a kind of mediator design pattern following program. So there is a difference. Means in design pattern also there is MVC, that is observer design pattern, but it follows mediator design. Now, when events are raised, either it is software event or hardware event, then event reaches the event dispatcher, event manager, or nowadays that is very famous, that is Qt application. Then we call it Q application, Q GUI application, Q core application. So the Q application and its ancestors, Q application and its family, Q application and its battalion. So they are responsible of kind of hooking into the device driver. The device driver which kind of responsible for sending the data or signal based upon the peripheral activities like a mouse and keyboard or any other peripheral we consider as external hardware. So external hardware, they kind of communicate with the kernel through a device driver. So kernel code, device driver is a kind of interfacing. So if we talk about interfacing, then it comes, it's a kind of, generally it is called adapter design pattern. So in adapter design pattern, two interfaces are different. One side is different and one side is different, and they both follow different protocols. So device driver is a kind of adapter design pattern where the kernel understands things in its own way, hardware understands things in its own way and react in its own way. So device driver comes into the picture and it behaves as an adapter. It is not a proxy. There is another design pattern in a structural design pattern. Mediator falls in behavioral design pattern. So in a structural design pattern, there is another guy called proxy. Okay, so that is different. There is another guy called bridge design pattern. There is another guy called decorator and another guy called facet. So these are kind of maybe probable candidate, but it is adapter design because both interfaces are different whatsoever. Now the queue application, which is a kind of the guy or the component that is responsible for kind of hooking into the device driver to receive the peripheral events or data. Now when event comes in, then events are kind of in a structured way in a device driver fashion. So it's a kind of byte string only or bit string only. Now its first job is to structure it in a kind of event data structure. When events are ready, now it will place in the event queue. So one guy we talked in the GUI programming is event dispatcher, event manager, or in QD application it is queue application. So or queue core application to the core level, which receives the event through device driver and it keeps it. Okay. Now when events are there in the event queue, then whom to dispatch? So the user who is using the software, the maximum what he can do is he can register for the he can raise events. That's best he can do. Okay, he can create windows. So two things are coming. One is creation of window which would generate the event. Means user can play with the window and he can generate the event, and generated event through device driver, if it is hardware event or the software event, it will reach the event manager. So two guys, window and event manager. User uses window and then as per the usage, window generates event and through hardware and kernel it reaches the event manager. Now what event manager would do? It has event, it change the byte code, byte sequences into event data structure. Now for the event data structure, function need to be called because user when he clicks something, he expects some operation based upon the clicking somewhere. So that is required. Now when someone creates a window, so what is the role of event dispatcher or queue application? So first role is it manages event. Second role is it filters event. Means someone can establish event filtering and few events would not be placed in the event queue at all. Means it is if it is unwanted. And third thing is event dispatching to the operation, to the functions. Now whatever window we are creating, those windows they register with the queue application, event dispatcher, event manager, saying that I am interested in these type of events, and this is my window ID. If window is generated for my window, if events are generated for my window, and if events are this, means the window guy is responsible for establishing event filtering. So if this crosses the event filtering, passes through the event filtering, then please make a call to this function. So a windows, so we can create a window and then register the window with the queue application saying this is my window ID, and for this set of events these functions need to be called. Okay. Now when events are generated, then it is obvious that when event data structure is filled by the event manager, window ID is attacked. This event was generated from which hardware? Now when window ID is received against each window, then it has a table, because after the window registration, it knows that against each event which window is the owner for the event, and then it maps for that event which callback need to be called. So that is what window manager registers with the application. I am the kind of owner of this window ID. All the event generated from this window ID, I am the owner. And for these specific windows, these are the mapped specific event. These are the mapped event functions. Now, if someone plays with the windows, he is generating events, doing nothing else. And then through device driver and other X11 that we'll talk later, X11 architecture, X server and window manager. But for right now, events are coming to the event manager, and with each event, it fills the event data structure where window ID is available. Now, since it has a mapping table against the window ID and for each event the callback function, that callback function gets called. So this much happens. If I see the conventional programming or console programming, we call the function. If user gave this input, then call this function. If user give this input, call, that much means that straightforward is not possible, because so many events may be generated in hundreds, in thousands in a second. So that much we need a mediator. Now, who is the mediator? Is the queue application. Event manager becomes mediator, and all event it receives, it mediates, and events passes through event filtering that is established by the window guy or indirectly by the programmer, and then those events first get filtered, and then if it is passing through, it will be placed in the event queue. Then event dispatcher one by one, all the events related to a particular window, means it knows the window ID, and then event and then its event callback function, one by one it get called. What else it can do? Means this is then kind of apart from I would say in addition to event dispatching, it does a window registration, and it does kind of window deregistration. So window can deregister itself from the event queue. So this kind of functionality that event manager does, and that should work smoothly. What else it can do? It can do event prioritizing. Someone can prioritize events, so that much feasibility also possible. So that when it is dispatching the event from the event queue, then it would check the priority of the event, and higher priority events would get dispatched. Means these are secondary. Means it behaves like a operating system, a process scheduler. Means process are scheduled in priority fashion, or inside a process, threads are scheduled in priority fashion. So that is kind of a GUI events programming. So we have two entities, what we learned. We have two entities. One is window and one is event dispatcher. Window registers with the event dispatcher, that is the queue application, also it is called in Qt program. And queue application works in mediated design pattern, where it hooks to the device driver to receive the actual event, because window is fictitious, guy. The actual event comes from the peripherals, and then the event comes in with the event data, signaling or data, with the window ID. So that much hardware provides it, and then it fills the event data structure, and then it processes the events, and then Windows, I would say Windows, they receive the event through its callback, what they registers with the window event dispatcher, event manager, or queue application. So it is kind of delicate. Means someone can kind of both means Qt codes are open source codes. So queue application or queue core application, rather, it maintains timers and those things also. So that can be browsed